Hello, my name is Greg Perugini, and I'm your instructor for Galileo's Bench Lab. And this lab is on parallax and star distance. So, if you remember from the first lab, how we see the sky changes depending on where we are. Our views of the northern polar region circle Polaris, because Polaris doesn't move in the night sky. Of course, it's in a different place if we're in a different place on Earth. But all the stars will circle Polaris as we turn on our pivot. So, as I said, they all are in the same place, but that isn't exactly true. There should be some movement. And this is what the ancients said. If we are if the sun is the center of the universe, a heliocentric point of view, then the Earth on either side, say in July or in January, you would see a parallax shift. We would see a star at a different location for a nearby star. You could see a parallax effect as well when you say, hold up your hand and you're blocking something, you open one eye and close another, you'll see your hand shift just briefly, just a small bit. That's a parallax effect. Now, the Greeks did not see that parallax shifting because, well, these nearby stars, even though they're nearby, are much farther away than they even imagined. So because of that, they didn't see this small angle change. So, if they did see it, and we could measure it, well, that's what we're going to do. We're going to see how, using a small angular change, we can figure out a distance to something. It's just a little bit of trigonometry, but bear with me. We can do a little experiment using the Galileo's bench kit to measure distance by measuring the angular displacement of an object. So, if we look at this on a triangle, let's define this is the adjacent side of this angle. This is the opposite side of that angle, and this is the hypotenuse. There are equations in trigonometry, you don't need to know them, that if you're given of these three things, you can get the fourth. Or if I'm given the opposite side and adjacent side with the angle, I can use tangent. Tangent of an angle is equal to the opposite over the adjacent side. So if I know either the adjacent side and the angle, I can get the opposite side, how high something is. Or if I know the opposite side and the angle, I could get the distance. That's the parallax effect, the distance to a star. Well, we're not going to measure distance to a star. As I said, the parallax is a very, very small part of an angle for stars. Too small for the Greeks to measure, certainly too small for us to measure without very sophisticated equipment. It's a very small part of an arc second. And in fact, we use that part of an arc second as a measurement, a parsec. Very, very small measurement. But we're going to do, show how it works. You're going to demonstrate how it works, the parallax effect. We're going to measure the height of a bookcase. Say you have a bookcase here. My bookcase is 2 meters tall. And we know that by using a tape measure, specifications of it. If it's a new bookcase, you have it in the manual probably. But you know the height of that. And we're going to use SI units, metric units. This one's 2 meters high. That's my opposite side. So now, I could take my swing arm protractor to get the angle. Now, I would hold that up to where my eye focuses, Okay? And measure from the bottom, have the bottom in my view to where the bottom of the bookcase is, and move the swing arm up to where the top of the bookcase is, and I would have this angular displacement. Now, that angular displacement, with just a little bit of math, if I can get the adjacent side, which is the distance to that bookcase, if I know the opposite side and the tangent of the angle. Now, in my example, I measured this, and this is about 25 degrees displacement. On the arm of my slide rule, the displacement was 25 degrees as I read it on my protractor. Your protractor might be a little different, but 25 degrees there from 0 to 25. That was the displacement in my view. So, using the adjacent side is equal to the opposite side divided by tangent of the angle. The opposite side is 2 meters divided by tangent of 25. I get an answer of 4.29 meters. And that's the distance to the bookcase. I didn't need to measure the distance to the bookcase. I used mathematics and parallax to measure the distance to the bookcase. So, find something you know the height of, use a protractor to get the angle, and you do the calculations to get the distance. And that's how you do the lab. Good luck.